Hey guys, welcome to Deep Dive Coding. Today we solve a LeetCode problem of the day, that is triangle. That is LeetCode problem number 120. So basically says that we are given a triangle, that is 2D array, and we have to return the minimum path sum from by the traversing from the top to bottom. Okay, so if you look into the first example, that is first row. In the first row there is only given the 2, and second row 3 4 and 6 5 7 and 4 1 8 3. So over here it is given that the 2, the first we start from the 2, that is top, and then pick the 3 and 5 and 1 will give the minimum answer. And also there is a constant given that triangle dot length, that is row numbers, can go up to 20. So if you look into the let's take an example, better example, then you can say let's try to approach greedily first. Then if let's say we are in the top, that is element of the 2, we can pick according to the question, that is just below of that, otherwise diagonally right. That means we can, if we place in the, if we in the 2, then we can pick the 3, that is just diagonally just below of that row, otherwise diagonally right position, that is 4. And if we in the 4, then we can pick the 7 or the 5, either of them. So if we try to solve this problem greedily, then we can, let's start from the 2, then we can compare that 3 and 4, which is the minimum, that is the 3 is the minimum. So we over here we write the 3, and after we place the 3, we are in the 3, and now we have to pick the below row, that is 6 or 7, which is minimum, that is 6. And we take the 6, that means we are in the positions at the 6, and if we in the positions in the 6, then we again start picking from the next row, that will be the 4 or 8. So which is minimum, that is 4 is minimum, so we again pick the 4, so its sum is the 15. But if you guys look carefully, if we pick the 2 first, then 4, and then 5, and then 1, this will give the minimum, that is 12. So the greedy approach is not work over here. So we have to think differently. Like it can possible that we are solving it greedily, but we are not picking the best path, we can say. So we don't know which path is the best at the starting position. So we have to explore all the positions, like all the possibilities. Let's say if we in the position at the 2, that is first row, then we can jump into the second row for any whatever the position. Like we again try to find answer by placing the 3, and find answer by placing by 4, and which is whatever is the minimum, we are taking that thing. And similarly for all the test state, like next row, that is 6 7 5, we explore all the possibility. Similarly for the next row as well, let's say that is the 4 8 and 1 3. So what you can see over here, that we have to explore all the possibility, and each of the possibility you can say the same operation, that will give us the recursions feeling. So first of all, I will in this video I will show the 4 approaches, like from the recursion naive approach, then memoization methods, then tabulations, then space optimized tabulations, whatever is given over here, that is follow-up questions, that is you can can you solve this problem in big one. At the last of this video I will show this thing. Now start from the recursion, as it is saying that we are starting from the recursion. Now we are given the triangle, and that will give the 2D integer. Now let's say first take the n, that will be the row size, that you can say the triangle dot size, and we are try to define a function that will calculate the recursively way, that we can say the name as minimum path sum utility function. And let's pass what are the things it can require. We are returning integers, that is the minimum sum and minimum path sum. Over here we have done spelling mistake. Okay, so yeah, sum and utility function, that will be, I will take the each state, that will denoted by, let's say, row as I, and int j as the column number, and we have to pass the actual state, that will be the triangle, and apart from that we are taking the row number, that is n. Okay, and now so over here we have to pass, start from the top, so it will be just 0 0, and this will be the triangle and n as we calculated over here, and we have to return this thing simply. Now we have to define this recursion function. Now first of all, the defining the recursion functions, we have to think about the that will be the, what is this here, base case. Okay, so base case will be that we are reaching the last state. After that state, that is last row, after this row there is no row is given. So whatever the sum at this point, let's say we are reaching the state at 8, so we have to simply return the 8 because we are not going further down. So the base case would be the last state, last row, that will be, let's say you have the n minus 1th row, and you have to return the simply triangle value, whatever value is given in that state. So simply return that thing. After that we have to think that what are the possibility, all possibilities that you can say that possibility number 1 can be go directly down, and another thing is go like diagonally down, diagonally down. Okay, so let's take an integer down, that is minimum sum. For if we choose the down as our first choice, then it will be simply, first of all you have to sum this thing, that whatever value it is given, let's say we are in the 5, so we take the 5 as sum, and then we are exploring 8 or 3, whatever we are whatever we want to check. So over here, as we are directly go down, so if we in the state in the 5, so if we in the state in the 5, we are going directly to the 1, we are exploring that situation. So again we call the minimum path sum util, that will start from I plus 1, that is the next row, and we again go directly down, so it will be the jth column, as currently I am ith row and jth column, and after that we have to pass the triangle and n as it is given over here. Now another thing is we have to calculate the diagonal number of diagonal sum. Okay, it will be again triangle of ij, we have to sum that value. Again we are calling the recursive function, that is path sum utility function, and it will be the next row, I plus 1 row and j plus 1 column, that is the next column from the current column, and in. Okay, now we explore all these two possibilities. There is no possibilities apart from that. Over here we also given that I and I plus 1 index of the next row. So now we have to take the minimum of these two. So whatever is the value we got till now, so we have minimum down comma diagonal. That means we are returning whichever is the minimum from the current state. Now I think it's fine, is okay. Now this is the recursive function, and let's run for the sample test case whether it is compiled correctly. Yeah, it's passed for the sample test case, so I will try to submit it, but it will give the time limit exceed. So but I will check, I will show you that how many test cases it passed. That means it's actually correct. Yeah, it's passed out of 27 out of 46. That means it's correct approach, but there is needs of improvement. So what we do, that I will just copy this function, I will copy this whole code and comment it out, and now I start the memorizations method. That means I have to, we are see over here at the current state, let's say you are in the state at the 2, you are starting from the 2 and you are reaching still the 5, and you are after the 5 you are storing that 5 positions, that whatever is the minimum next path sum. So whatever sum, like if you in the 5, you calculating further steps and storing the minimum sum at the 5. So if you reach in the 2, 3 and 5, similarly you can reach in the 2, 4 and 5. This thing also possible. So you are again and again calculating the same state. Let's say same state. I will show you by the code only. Okay, so if you want to see that whether it is calculating each same state recursively, let's say what is the current state, that is I equal to I, and just checking that it will again recursively going in the same state again and again, and same subset of the problem, so it will increase the time complexity. Let's check it. Okay, so over here, yeah, let's compile. Yeah, now let's check it, that what are the states it's calculated again and again. Let's say you have over here 2, 1. Okay, so I equal to 2 and j equal to 1. This state is also calculated, this problem is also calculated, and over here also 2, 1. So this is the these problems, the same subsets of the problem is again repeating again and again. We have to, and if we know the 2, 1 value, that is from the 2, 1 up to next, that what is the minimum sum, then we can store that value and simply return in the next next sub problem whenever it is occurred. So we just keeping the memory. Okay, now I delete it. Now let's take a vector, because we are taking vector because we are storing the value, which subset problem value, vector of int, and this will be the 2D array, and let's take n plus 1 vector of int n plus 1, and let's take a 0, as we are saying that we are not solved that till now. We are not solved because dp of ij is minus 1. So we are simply passing this thing in the question, like in this whatever it is function, and now let's input it as vector int dp. Over where we take the dp, and we have to pass over here also dp, over here dp, and now let's do the thing. Now we are always in the range, so if dp of ij not equal to minus 1, that means we haven't saved that value of the dp, then no, that is not minus 1, means it have the some value other than minus 1. That means we solved that problem already in the past, so we just return the dp of ij state, because that state will already calculated, and simply we return from the previous value. And for after each calculation is done, we are just simply update the dp of ij at the last that will be the final answer. So yeah, I think it's correct for the memorizations approach. Let's try to submit for the sample test case. Yeah, it's passed for the sample test case. Now let's try to submit it, whether it's accepted or not. I will show other 2 approaches as well. Yeah, it's still time limit exceed. It needs further improvements. Let's say tabulations approach, because we are taking the recursions, that will take the space, and as well as we are taking the extra space. Okay, so now over here I will go for the tabulation, that is let's try to copy again this code. Okay, so you can see that this thing, that once you write the recursion, then iteratively you can optimize it. So I will change it over a little bit, that you can say initially you have to dp of n plus 1, that you can say that it will be 0 state, because we haven't calculated anything. And now instead of return this thing, I will for now I comment it out. I will say why I haven't commented out. I have to remove at the last, and over here it is the base case, so we have to iterate all this base case. That means try to go for j equal to 0, j less than n, and j plus plus. So over here you can say that dp of I, that I is the n minus 1, and j equal to triangle of n minus 1 and j. That means at the over here also, that in the last row we are just simply return the triangle value, and over at similarly in this state, similarly in the tabulations approach, we are also only just populating the last row value in the DP state. That will be our base case. So I write over here that this will be our base case. Okay, so now try to explore all the things. If you look closely, that we are iterating over I plus 1, that means we are start from the I equal to 0 and up to the n minus 1th state, and also the j. And if you see that for the current calculation, let's say you have the current state and you need to calculation, so you need the I plus 1th state calculations. So what we can do, that we are backwardly iterating. That means let's I equal to n minus 1, I greater than equal to 0, and I minus minus. Okay, we do not start from the I n minus 1 because n minus 1 state is already done in the base case. So we start from the n minus 2th state, and again for the I not I, that will be j equal to 0, not 0, you can say, yeah, j equal to 0 and j less than n and j plus plus. Okay, so just I copy over here and just paste it. Now look carefully that how to change this code from memoization to tabulation. Now it's already calculating the down state. Let's copy this as well. Yeah, over here it's directly down. This is the calculating the down state. This is fine, the triangle of ij. Instead of calling again the state, again the function, we just already stored, because it will be the I plus 1th and j, because I plus 1 and j is the parameter. Okay, dp of I plus 1 and j. And over here also you can say this one, I plus 1 and j plus 1, I simply write over here that dp of I plus 1 and j plus 1, and remove this function. We just taking the help of the next step, and we are updating this thing, that dp of ij equal to minimum of down and diagonal. And at the last you have to return what you return. How can you guess it? You can say that, see this thing, that 0 0 we are passing I and j, and also dp ij is calculating the state of that problem. So you just return the dp of 0 0, and we remove this thing. Now let's try to sum, and we also remove this as well, because we are placing this thing because the help of that thing, we are want to take the help of that thing. And now it will be the tabulations approach. Now let's try to submit for the sample test case. Okay, it will give some error. Now let's check it. What is the error is given over here? What you can say, this one is, yeah, what you can say, I equal to 0, yeah, j, yeah, over here also, like we have to go up to that only. Let's say j less than equal to I. Yeah, so now let's try it. Yeah, it's accepted it for the it passed for the sample test case. Now try to submit it for the tabulations approach. I think it will be accepted. Yeah, it's accepted in 100% bits. That's fine. But now let's try to code for the space optimized version. Now you again look into this code, that we are only taking the help of the next step, that is dp of I plus 1th state, and also over here is dp of I plus 1th state. So there is no meaning of that. We are storing the all state of the row value. We just, if we only store the next row value, next row dp value, we just calculate the current state, and again we can swap that thing. So we just need the single 1D array. I will show you that. First let's try to copy this code, and I will change a little bit. Okay, and comment it out. Now the space optimized version. Okay, so instead of taking the dp of 2D, we just taking the dp of 1D array, and over here it is n plus 1, and you can say this will be the 0, and yeah, to go with the comma. And the base case, we are just simply remove this one because we are taking the n minus 1th state for the past. It will be the n minus 1 and j, that is fine. And in I equal to n minus 2, this is also fine. And for this one, yeah, we already, now for just check the current, now to store the current state, we have to take again a vector of 1D. That will be, you can say that current state of n plus 1 and 0. Now this will be the dp of I plus 1, that will only dp of j, and this will also have to remove, that is dp of j plus 1. Instead of dp I storing in the dp ij, we just store in the current state because dp is current right now defined in the next step. So we just take this saved in the input in the current state, and this is also done in the this one, that is current state of j equal to minimum of down and diagonal. At the last, we just update the dp as current state because we start calculating the previous state of the previous row of the current row. And now at last we have to just return the dp of 0 only. Okay, now let's try to submit the code. Let's try to run the code for the sample test case. Yeah, it's accepted. Now try to submit this code. I will discuss the time complexity, all the approaches. Yeah, it's also accepted. Okay, so now try to discuss the time complexity of it. So if you look into this code, that means we are exploring each and every state of the triangle, and that will be the each and every state, and that will be in the recursion function call. So you can say that will be the time complexity will be the number of row, that you can say row into number of column, that is whatever column it have, that will be the time complexity because we are exploring all the possibilities. You can say, yeah, it's okay. And for the space complexity, apart from stack space, we just taking the row into column vector, that will be over here. No, we are not taking the any vector over here, just we are, it is first recursion. Okay, it is first recursion, that means we are doing the only stack space for the recursion, that at max it will be the row into column number of recursions in the stack space. So it will be the space complexity. Now for the memoized approach, just let comment it out again. Yeah, okay, so over here we are introducing just an dp array. It will take you can say the time complexity. Again we are calculating the each and every step, but that step is quickly calculated because we are already remembering the state value if we already calculated in previous. So but that also, like, you can say that at max it could go big of row into column, and we are taking the extra space, that will be the dp array, that will also take the row into column. Also we are using the stack space for the recursion, but the stack space will be a little bit less as compared to the above one. So you can say that also row into column and 2 into row into column, that you can say the big of row into column as the space complexity. And for the tabulations approach, I will show you this thing also. Yeah, for the tabulations approach, we are also taking the 2D array of dp, and we are calculating n minus 1 to 0, n minus 2 to 0, and also over here is 0 to I. That means you can say that this is these are the running of the n square complexity. You can say that will be the time complexity, big of row into column, and space complexity would be again row into column because we are again taking the 2D space, but it will not take any extra space because we are not using the recursion, we are not extra using the stack space. Now at the space optimized approach, what we have done is over here we are taking the only single 1D dp. Over here also 1D dp, And you can say the time complexity is not updated, improved, that will only n square time complexity. So you can say the time complexity will be row into column, and space complexity will be updated for that will be, you can say the row you are taking 2 extra space, that is you to at a time you are taking the current state and dp. So you can say 2 into row, that you can eventually say that this will be the big of row. And over here it is saying that you can consider the row as a n. So yeah, over here it says that you can do n is the total number of rows. So we done this follow up, and this will be the state optimal approach. Now if you guys reach till now, thanks for watching. Stay tuned for the more videos, and feel free to comment if you guys found anything helpful. Thank you guys. Bye bye.